Hello, everyone. My name is Hal Paris. I'm with L3 Harris. I'm the Director of Simulation and Training Systems. And what I'm going to be speaking about today is expanding into immersive 3D reality and digital twins. Now, we've had a lot of history here over 50 years. You just saw Bernard talking about our new instructor station, and I hope you did understand how portable that is. And I just want to share with some of you during COVID what can be done here. You can take your tablet computer and go sit in the backyard and run the whole entire simulator. It's quite amazing. So I'm not going to go through each and every one of these innovations that we've done. I'm going to talk about the one in the lower right corner, which is the digital twin. So you know us for our computer simulation experience. It's quite extensive. And if you think about it, what could you do to expand that? Okay, we have the process simulation firmly in hand, but we have all the other technologies, laser scanning, virtual reality, 3D CAD, computer systems, database, BIM, construction scheduling, and things of that nature. But normally these technologies are known by the people that work with them. And so what we asked ourselves, is there a way to access this information and make it available to operations and maintenance training, outage planning, things to do radiation dose reduction, and introduce the concept of a single source of truth. And so what do we mean by that? Is that when you get ready to do some maintenance or procedure or something like that, you have to know where to go get the data that you need, whether it be a PNID, a schematic, an isometric drawing. There should be just one source of truth where you can access all of this information before you start your work or you do your procedure, things of that nature. So, you know, the new plants are all done in 3D CAD, right? We've found a way to ingest all of that information and capture the as design configuration. And this is of the entire facility, not just certain systems or rooms, including the external the layout of the plant. And then as well, you can go ahead and laser scan and get the as-built configuration. And that's very important. And any of the people that have actually worked in a power station, what you think is there and what is there can be quite a bit different. Things such as CAD does not include things like lagging on the piping. So you may think you have a certain amount of clearance, but then you get there and you find out it's a lot smaller than what you had planned for. So the accuracy of these laser scans are down to 1/8 of an inch. So imagine for outages, and you're going to remove a piece of equipment and put another one in. How do you navigate that piece of equipment inside the facility and ensure the best pathway? So having this data available is really transformative. So again, as I said, construct a complete 3D digital replica. We already have the process replica. So now we're going to make the physical replica, and we're going to integrate the two together. And then all of the information that relates to a particular piece of equipment, like a tech manual or a PNID or set point data, you could be able to access that through our 3D environment. So while we're there, why not? When you look at a piece of equipment, you should be able to animate it in 3D. And this is more for a training or a maintenance type of procedure. But rather than guess how it works, actually see how it works. And so from the 3D environment, you can select certain pieces of equipment and see how they operate. And I'm talking about the internal operation of a valve or a pump, something along those lines. So you can see what we're doing here is trying to increase the efficiency, okay, of learning, whether you be a maintenance guy, an operations person, an outage planner, and be able to interact with that with all of your colleagues. Because when you work in a power plant, you don't do that in isolation. You're working with other disciplines, mechanical, electrical, and you need to be able to discuss certain things. So this is an old slide that said, what would it look like? Okay, this is what it does look like. Okay, this is a picture of what we've been working on here for the last year and a half, where we've actually presented the 3D digital twin, the entire facility. It's integrated to the simulation as well, because there are certain local panels or remote valves. You can actually operate them from this 3D environment. As you can see, it's got photorealistic quality, and you can click on certain components like the valve that's shown here and get information about it. You can also do scenarios, even do training for fire, things like that. And you can see the pathways. Because one of the things that's really important is that in any nuclear facility, while it's operating, you cannot go into the reactor building or the containment building. And hopefully you're operating for 18 to 24 months before you go into refueling. When you get ready to go into a refueling outage, you think you know where everything is, but chances are you don't remember because maybe you haven't had to do a particular operation due to it wasn't your turn. So it could be even longer, it could be 4 years. So this allows people to understand what they're going to be interacting with in things just as simple as where are the wall outlets, okay? These are real practical, kind of ridiculous things, but that do happen. So this gives you an idea to you and your colleagues can very well plan out exactly what you're going to be doing. So you can put in the tag for the component. It flies you to the room, okay, where that component is located, or you can do it the other way around and go to specific pieces of data. So it's interactive in both ways. So here's a little video of a little avatar that we placed in the reactor building. As you look around the room, you see you could be reading a procedure and it says, go to this valve or that valve. And where is the valve? Oftentimes, they're not right at shoulder height for you to operate. In fact, more times than not, it's not. You may need a ladder. You may need to build scaffolding. And without really being familiar with the room, you can't even make those decisions. So think about outages with people that are subcontractors that come into your plant, and it could be up to 1,000 to 2,000 per outage, and they're going to be working on something that they are not familiar with. And oftentimes there are unknowns that get identified when they're trying to plan their work. And furthermore, add to it, and I'll talk more about this later, is the radiation aspect. You don't want to be in these high rad areas for a very long period of time. And you certainly don't want to be increasing your dose rate while you're planning your work. You want to get in there, get it done, and do it very efficiently. So again, the idea of our digital twin is that we integrate the simulation along with the mechanical components. And what you see here on the right is it's a main condenser, and we're animating the steam flow. And imagine if you're a student who's never been in a power plant. You listen to the PowerPoint presentations, you hear the instructor, he's waving his hands. Why don't you just show them, okay? They very quickly can understand exactly what the environment is, relative size, how it operates, and you can go between the simulation and the actual physical 3D representation. So I think it makes it pretty obvious that you can learn quite rapidly in this. And if we think about the nuclear industry as a whole, we have a lot of young people that are entering the workforce, and they expect this kind of learning. They do not want to listen to an instructor babble on for something that might take 30 minutes when you could just show it to them and they get it in a few seconds. So I think that's important for a lot of reasons. So let's talk about radiation a little bit. Is that when you go into the containment or the reactor building, there's been radiation surveys are done, okay, but they're not, it's hard to understand exactly where, taking into account shielding of the piping and the casings and all of this, where is the lowest dose rate? And if I'm going to be working on a piece of equipment, I personally would want to know that. Likewise, the subcontractors that come in for outages, they don't know exactly where the radiation sources are. It would make sense to be able to show them and imagine it's kind of like a cloud, okay, that measures the distance from the radiation source. You can see where the high rad areas are. You can see where you might want to position yourself. You can also add lead shielding. The model takes into account the shielding from the radiation, so you could actually physically move the shielding around in the 3D model and see how the radiation gets attenuated. And every nuclear plant has to keep track of the overall cumulative dose rate for the workforce, and this gives a way to actually reduce it over time. So, I mean, it'd be great to have a 3D plant on your desktop, but how can I view it is one question. And I know a lot of you are experimenting around with virtual reality. I personally played around with it for quite a while, and it's uncomfortable, okay? It's a single user experience for the most part, although there are multi-users that you can use, but it's still very uncomfortable. And basically it makes you sick, physically sick. You get dizzy, you can't use it for very long. And in a work environment, you can't even jot down a note or sip on your cup of coffee. So there needed to be another way to access the 3D representation of the power plant. And here it is, okay? So in the power industry, as I mentioned earlier, we work as a team, okay? We need to point, we need to talk, we need to look at data, and there needs to be an environment where you can do that without any headset or goggles. A lot of the people that work in the power industry, they're not that big of a fan of technology. They don't want to play around with headsets and goggles and all of this, but in this display that we have here, as we call it, Orchid IX, a number of people can get in to the plant and it looks as if you're really there, okay? So the applications, okay, think of an instructor and a student. Rather than the instructor trying to describe what it looks like, he can show them what it looks like, and the student gets it, or workers or supervisors. And as I mentioned earlier, electrical, mechanical engineers work together. You've got to get the power to the component. The mechanical guy doesn't really care about the power, but he needs it, and you can plan that work out. Contractors, I mentioned, and also plant security. Plant security is responsible for the whole entire site, and they may not be all that familiar with what the rooms are called, things like that. So they can use this as well. And of course, outage planning and management. So we have three different formats, one for up to 2 users, up to 6 users, and up to 15 users. And you can see there's plenty of room in there to be able to be a normal human, okay? And you really get the sense that you're inside your plant. So how does it work? So basically, we call this reflected reality. And what we're doing, you can see number one, the little camera down there. And we have 7 projectors around the room. So not camera, but projector. So it shines on what is a curved piece of a mirror system, which reflects on this mirror here. And what you get is you get complete depth perception. It's not flat, it's curved. And it looks like you're really standing there. So again, we want to integrate this to all the different data sources, and we call this our digital twin framework. So we have all the things going into the system and all the things coming out. And so you can access this type of information when you're standing in the dome there. And so what we've done is we have real-time access to 85,000 individual components. And just think about that. And think about as you do your work, all the drawings that you have to go find and assemble and try to digest. This is a whole different way of working in a power plant. And it doesn't necessarily need to be a nuclear plant, it could be a gas plant for that matter. It really is very accessible. And really why we're doing this is efficiency. It's not only efficiency of learning, it's efficiency of work planning. I think you get the idea. So what we have here is a fully immersive you get inside and you look out and you see your plant, right? And you can do measurements, discuss with people, plan work for outages. Things that I think are cost justifiable here is you think about the outage cost. When a plant is operating, on average, it generates $1 million worth of revenue a day. So if it's shut down in outage, okay, that's $1 million of revenue that you're not generating. Add to it the subcontracting costs for you to do the outages, that could be another $2 million. So for every day of outage time lost or saved, it's in the order of $2 to $3 million, and that's significant. And I think a lot of us have been involved in outages that things were not known. You discover while you're doing it, and then the clock, could be another day, another week, and sometimes another month. And you can do the math there and find out the financial significance of this. And we're trying to reduce that. And so it's available for all of the different disciplines that work at a power plant. It's just not training. Training certainly benefits from it, but it's a way of changing the way people do their work. So we're really excited about it. And if you have any questions, there's my email, and give us a call. Thank you.
Hi. Do you know simulation? I am the simulation. Do you know who I am? I am smart, but together we are smarter. I am digital. I am hardware. I am visible, and I'm not visible. I can be one, and I can be many. I can be the task or the solution. I can fly, drive, swim, and dive. I have a great network. I am virtual, constructive, live, or a process. Together we can learn the basics and try out your tactics. We can achieve a goal together and start over again. Together we see the future, live the present, and analyze the past. I can be any person you want me to be, but I am always your partner. I am flexible. I am mobile. I can assist your coach or be your guide. I can be your team player or your opponent. I can work for you or we work in groups, but you find me wherever you are. I am the simulation. I am a part of Rheinmetall.
Sicherlich kennen auch Sie die Situation.
You certainly know this situation. Once your plant is being operated, new data is permanently generated and existing data is modified. To be more precise, your entire plant as well as equipment is documented in the form of data. Everything you have to know about your plant, everything that really matters, is spread all over numerous software applications, databases, and paper-based files. This means this data and information can neither be accessed easily or quickly, nor does it have any useful correlation. We call this data dark data. Let's be frank. Can you actually rely on this data? What really matters is how the data can be managed efficiently across different disciplines and along the entire life cycle in order to provide relevant information for substantial decision-making processes.
Und hier kommt Planzeit ins Spiel. Planzeit wurde speziell für die Prozesse.
Here, PlantSight comes in. PlantSight has been developed in particular for the process industry and consolidates all information and data, be it static or dynamic. You can consolidate, contextualize, validate, and even visualize your data and information with PlantSight. The raw data is then transferred to a complete digital twin.
Ein lebendiges Abbild Ihrer Anlage.
It is a genuine copy of your plant, which is being updated on a regular basis and grants valuable insights. Suddenly, you realize new correlations and understand how everything is interconnected with each other, where to go further, and how you can actually work with the data right now. It doesn't matter whether you are an operations manager, site manager, engineer, or operator. PlantSight helps you reveal yet hidden data, make decisions faster, and thus increase the profitability of your plant immediately as well as on a long-term basis. All this is possible with only one simple web portal, which can be easily accessed. A completely new portal allowing for realizing and enhancing the added value of the digital twin along the entire asset lifecycle in process industries. Anytime, anywhere.
Jederzeit und von überall.
Siemens. Ingenuity for life.
Welcome to this session from Siemens. Here we're going to address the immersive training simulation for remote operations. Today's presenters are Nigel Sams and Andoni Gonzalo. I'll start by just addressing some of the challenges and positioning today around digitalization. So digitalization is upon us. It has been for some time, and a number of companies have started their journey, come some way in that. Some are yet to start. But essentially, digitalization is this fourth position of industrial revolution. The industry, process industries especially, are looking for new business models where they can address their need to reduce time and cost, to improve efficiencies, to maintain and improve quality, whilst giving consideration to all of the external aspects such as environment, health, safety, and of course, security. If we look at where the digital transformation in the industry is today, then it's looking to exploit all of these areas such as digital twin, reliability, operational excellence, incorporating analytics and AI, and of course, the Internet of Things with big data. If we look at the illustration on the right-hand side, we can see that probably close to 60% of the benefits can be found in these three areas. So, health, safety, and environment, very important. Reducing costs and changing the way that companies do their day-to-day operations. It's not that the rest is insignificant, because we can see that there are great areas there, such as bringing plants and physical assets into a virtual environment for virtual access. Siemens has been part of these industry changes since the end of steam power, when electrification became the area of focus, which we refer to as Industry 2.0, progressing then to automation of plants, and now in this digital era for digitalization and Industry 4.0. Siemens itself is a really large company, but within Siemens, we have an industry software division, which is within the world's top 10 software providers. And you can see some of the figures here, where we have market share, the approximate expenditure that we have in R&D, and the number of developers, patents, and so on. Let's get on to the challenges here. The challenges of ensuring that our virtual environment is aligned with the real plant at all times is a big challenge, but it is a challenge which will give these benefits to the operating company. The ability to find information in one place, not in siloed, disconnected areas. So we're going to progress now to addressing how to provide a continuous virtual world of the real world, the process plant or facility itself. So Siemens, in collaboration with the strategic partner Bentley Systems, has developed a solution which we've branded as PlantSight. Within Siemens, we've identified 6 different business areas which PlantSight can address. If you see on the left side here, this is really the DNA part of the plant. It's the engineering information. It's the data which is being created from the very early stage, used through concept, and enhanced through engineering to be able to construct and deliver the physical asset. If we look on the right-hand side here, this is when the plant is in operational status. You can say that this is the pulse and the heartbeat of the plant. So combined with the DNA itself, it gives some extremely meaningful insights to all stakeholders on the plant regarding the full plant and the individual actors in the plant. One example, if we have some critical equipment that must not fail, we can provide trending information as to how it's operating, and we can make decisions potential decisions to offset maintenance if it seems it's not required. Inversely, if we look like we're going to need to maintain it before it's planned, then we can make that decision based on this insightful information. This session is going to focus on immersive training simulation. And at this point, I'd like to introduce my colleague, Andoni Gonzalo.
Thank you very much, Nigel, for your introduction. I will be presenting how we are helping customers to tackle their health, safety, environment, and quality through an immersive 3D viewer and simulation. So, what is an immersive 3D viewer? Well, this is a real-time visualization software that allows immersive collaboration throughout the life cycle of the project. I also like to say that this is an immersive 3D portal to all the information of a facility. Basically, it will allow you to have a true immersive experience with your visual asset as if you were within the facility itself. When we talk about healthy, safety, environment, and quality, we are talking about making sure that all our workers have the needed competencies to perform their work. For this, we need to make sure that they are able to get trained on a safe environment that simulates the real plant. In order to achieve this, we at Siemens use our immersive training simulator that helps enhancing the operators' competencies through immersive training. Our ITS, or Immersive Training Simulator environment, is thought to be used by non-CAD experts, like field operators personnel, and therefore is a very intuitive platform that helps the operator train himself even from the comfort of his own house. Of course, field operators may need to gain competencies on different areas. For example, they may need to know the facility because they have never been there before. So simple familiarization training to learn how to move around the facility will be very useful. Another use case will be when an operator wants to reassure himself on his daily work. In this case, the operator may have an overview of the standard operating procedure on the immersive environment, so she feels much better prepared when it's time to go to the field. Of course, making sure that the workers are ready to react to any unexpected incident is critical to reduce the facility downtime and in some cases even to save lives. For these cases, HSE-related competencies can be gained through the incident-based training scenarios. Last but not least, when we want to gain team competencies, an immersive multi-user environment led by an instructor is a must. As these teams in general include field operators and control room operators, the integration of the immersive training simulator with the available operator training simulator, which is in general already available, is really useful. In this case, all the team members that take different actions during, for example, a startup procedure can gain the needed competencies together. So, how do we do all this? Well, the capability to integrate different 3D sources into a single 3D real-time session gives the user the opportunity to integrate full facility models. This integration may contain data from 3D CAD design tools, mechanical 3D drawings, or brownfield datasets, like photogrammetry-based 3D meshes or point cloud data. The complete overview helps providing the user a real immersive experience to take the right decisions at the right time. Therefore, as an example, we could have the design of a plant done in E3D or a smart plant, where the different vendor packages are integrated through open formats like STEP or JT, or even though through ProEncode, for example. So how does the workflow work? First, the immersive project is built from any of the supported CAD sources or brownfield sources, like mentioned before. Then the immersive project is uploaded to the server. And after that, what we call an enrichment process can be done to add further intelligence to it. This is normally done when the project will be integrated as part of an asset management solution. Of course, at this moment, is also when all the training material, including the standard operating procedures, can be added. The final project can be visualized on any of the supported environments, like VR, web, desktop, and so on. One very important topic to keep in mind is the workflow automation. We believe that the complete process must be automated in order to quickly be able to rebuild new versions of the same project. This way, we can keep an evergreen immersive project that operators can really rely on. This being said, let's move on to the live demo, where we will show the integration between our cloud platform PlanSite that Nigel has introduced before with our immersive 3D viewer walk inside to enrich the competency training management. So here we can see our PlanSite environment, which is running on the cloud. And in the coming session of tomorrow, you will have more insights about it from Gerd de Nul. On my side, I will start our journey by searching for a pump that we have found that has too much vibration. As we have all the data very well aggregated, I can easily make a quick search in order to navigate to the area where this pump is located. I will now rotate the camera to get a better view of the area, so I can have a look to my twin system where I have the pump that is actually vibrating. On the other side, we have the pump that we want to start up in order to be able to do some maintenance on this pump. So in order to do that, what we can do is actually to create a procedure. How we do that? Basically, we create first a scenario that is going to be called HG3066A startup procedure. Now, once we have created the scenario, we can add steps to it. The first step is going to be to close the pressure valve. So we are going to click on the valve, and I'm going to create my scenario, my step. The next step is going to be to open the suction valve for that corresponding pump. Therefore, we are going to add the step to the suction valve. Next, we need to switch on the pump. And this is our HG3060A pump that we are going to start. Next, we are going to slowly open again the pressure valve. Okay, so I'm going to add this one here. As we can see, we get a notification of two. Oops. There you go. So now I can add correctly my next step. The next step is actually to check if there is any leak, and therefore, in case there is any, we need to clean it. So we will check if there is any leak there, and if we find any, we need to make sure that we can clean it. Now that we are done with the startup procedure, we are going to go for the shutdown of the pump B. So the first thing to do is to close the suction valve. So we'll make sure that we click on the suction valve. Let's go. Then we are going to switch off the pump. Go. And finally, we are going to close the pressure valve. Of course, at the end, we will need to inform our control room operator that we are completely finished. Finally, we can review the work we have done. Okay, so here we can see that we have step 1, close the procedure, step 2, open suction valve, step 3, switch on pump A in this case, open the pressure valve slowly again, check and clean the leak if there is any, and then we start with the closing part. Close the suction valve for pump B, switch off the pump B, and close the pressure valve. And finally, inform our control room. So the next step is that we are going to push this procedure into our immersive 3D viewer. And whenever this is done, we will be able to start our immersive environment in order to run the procedure or the scenario. So now we are going to start our environment. And what we have decided is that in this case, well, first of all, I need to log in. And as I have already logged in before, and we are using a single sign-on, we can directly walk inside, in this case, which will be our immersive 3D viewer. We have decided to take the training into the night shift. So you will see that we will be starting a lot of lights and so on. So there is an immersive environment that looks like a night shift. So the operator can also train during the night. So now, this is our immersive environment. And here we are going to enable the toolbar in order to be able to run our scenario. So now when the scenario starts, everything is dark because we are at night. So I'm going to start the scenario so all the lights come in, so to get a real immersive environment. Now I'm going to complete the steps that we have already prepared before. So the first thing we need to do is to close our pressure valve. In this case, this is the one. Next step is to open the suction valve. Now I need to start my pump and slowly open the pressure valve again. As said, I need to check if there is any leak, and in this case there is, so I will go ahead and clean it. Now we are done with that part of the scenario, and now we are going to start with the second part, which is to stop the running pump. So the first thing is to close the suction valve. Then we are going to switch off our pump. And finally, we are going to close our pressure valve. Last, as mentioned before, we are going to inform our control room that we are finished. And when we are finished, we are getting our report. Okay, this includes all the events that have happened, including the starting of the lights, all the actions I have taken. If there will have been any error during the scenario, this will be logged in here, and we can save this one either as an HTML or XML. So later on, we can actually post-process this and upload it into the plant site environment for future reviews. So this is all, and I'm going to hand it over again to Nigel. Thank you very much.
Thank you, Andoni. Really good demonstration, live demonstration. So I'd like to finalize the session with some key takeaways of what you've seen today. Immersive 3D viewer, in order that the operator can immerse himself in a virtual world and be able to interrogate information, either 3D models or associated information, to give those meaningful insights. Capabilities and the benefits to be able to improve competencies through immersive training, field operator, control room, personnel integration in a collaboration and bring these competencies together, to be able to create and execute standard operating procedures, as was demonstrated for a a simple change from one pump train to another train, and a very easy, simple game-like immersive environment with a low training threshold. Here's our contact information. Thanks for your attention. Please come and visit us on our booth and watch out for the next session around digital asset portal.
Hi. Do you know simulation? I am the simulation. Do you know who I am? I am smart, but together we are smarter. I am digital. I am hardware. I am visible, and I'm not visible. I can be one, and I can be many. I can be the task or the solution. I can fly, drive, swim, and dive. I have a great network. I am virtual, constructive, live, or a process. Together we can learn the basics and try out your tactics. We can achieve a goal together and start over again. Together we see the future, live the present, and analyze the past. I can be any person you want me to be, but I am always your partner. I am flexible. I am mobile. I can assist your coach or be your guide. I can be your team player or your opponent. I can work for you or we work in groups, but you find me wherever you are. I am the simulation. I am a part of Rheinmetall.
At Emerson, we are proud to serve essential industries that meet critical global demands and make modern life possible. The needs of these key industries, like life sciences, power, energy, and food and beverage, are transforming and growing as our customers encounter more complex challenges amidst the shifting global and economic landscape. We are helping our customers rise to this challenge every day, providing advanced technologies and expertise built over decades of leading domain knowledge. With our $2.2 billion software portfolio, we are empowering customers to use automation to optimize their operations and realize the benefits of pursuing practical, scalable digital transformation. We enable our customers to use technologies that create safer, more sustainable operations, enhancing reliability and top quartile performance while creating tech-focused, secure jobs for the workforce of the future. Emerson offers a broad range of devices and sensors to allow companies unprecedented insight into their vital equipment. Whether in a pharmaceutical company or offshore oil platform, enable precise management of complex machinery. And we are continuing to build on our strong software and data management technologies to give customers real-time data and operational analytics to identify areas for improvement and to find problems before they occur. We have seen firsthand the impacts of automation in daily life, and in moments of challenge that are accelerating the need for digital transformation. We have been working closely with more than 20 pharmaceutical companies to automate operations so they can more quickly manufacture life-saving vaccines and treatments. We have quickly pivoted to meet changing manufacturing capacity needs amidst the COVID-19 pandemic, and we are positioned to help our customers continue exploring automation as a value driver for decades to come. Everything we do at Emerson supports essential industries and drives innovation that makes the world healthier, safer, smarter, and more sustainable.
Okay, good morning and good afternoon, everyone. It's great to be speaking with you today. My name's Ronnie Baines, and I'm responsible for the digital twin and process simulation business within Emerson, supporting the European region. So today we've got a presentation that's really talking about the digital twin and how it's really going to assist with the future operations of our facilities. So we've got a few slides we'd like to share with you to really set the scene of what the digital twin is, the types of digital twins which we're delivering to our clients, and then we'll look at how it can really assist with getting readiness and operational readiness for the operations of the future. So to begin with, we see the digital twin used as a term very widely and broadly within industry. So there's lots of different definitions and understandings of exactly what that digital twin is. But to really get a common understanding, as you can see on the screen at the moment, each of these types of disciplines have digital twins. So there's a mechanical type of digital twin, which is really focused on much more on etching material and the kind of the asset itself. We have a process digital twin, first principles based, and that's the type of digital twin which we'll be talking about today. An immersive digital twin, which really takes account of 3D CAD and virtual reality to get a feel for the outside environment, and as well as analytics. So lots of different types of digital twins that we do actually develop within Emerson, but for the purposes of this discussion, we're really focused on the areas in green, so the process and the immersive, just to kind of set the scene of what the context is here. So we recognize that a digital twin really must be a practical investment for every operations and project person within a facility. So it must meet the needs of different stakeholders within an organization. So the first principles model must be able to meet the needs from process engineering, from control systems engineering, through to the needs from operations, maintenance, and once we get past that phase, it's how does it support the day-to-day and ongoing operations of a facility. So we see it as a tool that can be used from very early on all the way through from design down to the operational phases of a facility. And within our view, there are several things that a digital twin must be able to deliver upon. So the first one, it needs to be able to represent the physical assets, so the physical production world with a software representation of what it's trying to do. And we do this with our digital model that we develop. The look and the feel must be very similar, if not identical, to what the real world looks like. So whatever we build in our digital twin environment must look and feel very similar to what the the physical and production system is. The ability to simulate at different levels, so depending on what the use case is, depending on what the piece of equipment is, we vary the level of simulation and the level of accuracy which is needed to simulate that. Data is very important. Data has become increasingly important in our industry, and a digital twin is much more than just a dig dump of data or a repository of data. It must have that interrelationships connecting the data to really make it useful and relevant. And finally, have the ability to connect to real-time data. So actually bring that data from the plant straight back into the digital twin to further use and refine the tuning, the performance of the digital twin, and also the types of use cases of how it can be used when we look at an operations perspective too. So the digital lifecycle is an important concept and really is something that we endorse within Emerson. So across the top of the slide, you can see we've got typical phases of a new facility, starting with concept definition, where we design and get initial design cases, and we get the authority to go forward and build a new facility. We then build that process design, validate it. We then come to a point where we need to build and think about designing our integrated control and safety system. And eventually we commission, start up, and then it really moves into a phase of operations. So the digital twin is something that can be used throughout all of these different phases of an asset's life cycle. So starting with feed studies, doing those early conceptual designs, learning more about the process and evaluating and validating them, can then be used to develop procedures and test those procedures, pre-tune all of your control strategy and test it completely virtually and non-intrusively. Virtual commissioning is something where we're actually able to commission our complete control layer on a loop-by-loop basis using our digital twin. Again, doing this much earlier on in the design phase, sometimes when the actual physical plant is not even available. And once it's been used for this virtual commissioning, we can feed that back into the main project team and then use the digital twin as a test bed to develop more advanced control techniques with advanced process control and optimization. In parallel, we can verify all the operating procedures and, of course, training and competency assessment. So that's a huge use case, conventionally, which a digital twin or an OTS has been associated with. But prior to using the system for training, there's a huge amount of benefit that can also be realized. As well as this, once the system's used, we would then apply it to optimization, debottlenecking, and really working towards autonomous operations, because that's what we see the digital twin as being able to do. It's a tool that helps us get ready for the future operations of how our plants need to be run, and autonomous operation being at the center of that. So within Emerson, we have a couple programs that really help our customers both deliver projects efficiently. We call that project certainty. So it's really about getting a project up and running as quickly as it can, taking account of all the changes that happen in a project environment, meeting schedule, meeting budget, and using all the tools and expertise we have in the organization to be able to do that. We also have something called operational certainty, which then transitions to the operational phase. So how do we maintain the operations and help our customers run their plants as efficiently and effectively as they can in terms of reliability, safety, and emissions? We see the digital twin as a key building block, which can support very early on designs and support projects, and then transition very easily through to support day-to-day operations. So really living alongside the asset itself. So with this in mind, there are many benefits that our customers are seeing with using the digital twins we're delivering, and some of them are shown on the screen at the moment. So the first one is every digital twin we deliver, there is always a reduction, but a saving and commissioning of the control layer. So be that a greenfield facility or be that a brownfield, typically it's in the region of 18 days. And depending on the industry, we can then put a strong return on investment message together. There's always an improvement in the operator effectiveness, and that's usually greater than 30%. So it's a better understanding of how the process is going to operate and what the actions are which need to be taken. Having that forward view really helps the effectiveness of the operator. Less unplanned shutdowns, so being able to run the plant close to the operation envelope and running it harder, more effectively, being able to get more productivity out of it. But when there are shutdowns, because sometimes they happen, being able to get up to a running nameplate capacity quick, better understanding of the right steps to take and how to operate the plant. So this really comes down to having a strong return on investment, and typically we see it's over $50 million per asset, per facility. That's the type of return on investment which we've achieved for many of our customers using digital twin technology. A strong return on investment, and as well as that, there are also many secondary benefits, things like increased reliability, reduced maintenance costs, and ultimately, getting the right product out to market quicker, so much less product waste. So you can see there's a very strong value proposition of how the digital twin can be used and applied to operations. So to really put this into a kind of the next phase and understand how the digital twin sits in the future, we've got a little video that we would like to play to you just to show the types of technologies that we see our facilities of the future using, and how the digital twin is an important part of that, an important concept, really pivotal to ensuring that happens correctly, and how those plants can be run even more effectively going forward.
We see engineers simulating the future to improve today. At Emerson, when issues become inspiration, creating a better world isn't just a result, it's a responsibility. Emerson, consider it solved.
So, which of the technologies that we saw in the video just now are being deployed and used today? Today, we're using the digital twins in order to aid migrations of control systems, modernizations or replacements. We are using the digital twin in projects to test and develop control systems, to train board operators, both on the process and the control side, and to have it as a tool for operational support in order to see how to operate the process in a different or more safe way. Currently, the digital twins are either available as a physical system or on the cloud, and they can be online or offline, mostly offline, but there is more and more usage of the digital twins online. The other technology that we saw in the video that is used today is the virtual reality, meaning the 3D environment, where one can navigate inside and access hotspots of instruments and readings across the process. This technology is currently used for field operator training, to train field operators on the operating procedures to start up and shut down the plant, or the normal operating procedures to do changeovers and prepare the plant for switchover, let's say, of a pump. You use the virtual reality or 3D simulators in order to train the teams of board operators with the field operators and check the dynamics of the team and also the communications of the team. And you use the 3D simulators in order to carry out maintenance training, so prepare the maintenance staff to identify the equipment that they need to maintain in the plant, and review the components and the procedures that they need to do in order to carry out the maintenance tasks. Finally, you can use the virtual reality for monitoring the health of assets. There is also the augmented reality that we saw in the video. This is basically accessing live data, procedures, or diagnostics on a mobile device. So, for example, a field operator goes to the field, but he needs to review the operating procedures, so he can access them on a mobile device. There are other devices that enable the collaboration between the field operator with experts. So, for example, the smart helmets. The remote expert can see what the field operator is looking at and guide him through to complete a task or troubleshoot the problem that is in the field. There is the geofencing technology, whereby you can alert an operator who is entering in a dangerous zone that requires protection equipment. And you can also guide them through to the location where he needs to go in order to access a field instrument. And you can also show them on the map the route and also guide them through like a GPS. Finally, there is the X-ray vision where one can see what is behind the protective screen without accessing or opening the protective screen or the cabinet door. So basically, he can see a virtual representation of what is behind and then assess whether he needs to open that cabinet or move on to another one. What are some of the new technologies that are coming, not currently used, but coming? So some of these technologies are the machine learning. This is actually currently implemented in our technologies. So machine learning is basically a technology which helps to turn data into value. So you can use historical data in an offline mode in order to train your machine learning algorithms to recognize certain patterns. For example, the degradation of equipment over time, and use that information in order to predict when a failure will happen so that you can plan maintenance to that piece of equipment before the failure, which can be very costly if it causes a shutdown of the plant. Then you can also use the data online by connecting the machine learning software to the online system through historians. So they can pull the new data. For example, if you have changed the feed to the process, your process will behave in a different way. So it is one of the things you want to record and get historical data for in order to further improve your machine learning algorithms, and also in order to tune the digital twins and align them to the real plant behavior. There is another technology, the pattern recognition, which has many components. So you can have voice recognition, face recognition, gesture recognition, or other biometrical data recognition. So for example, a heart rate of a person who is on the field in a dangerous situation. So what this pattern recognition is used for is to set the access level and the security, enable the security protocols to recognize whether this user should be there, and also to identify whether the field operator needs assistance. And finally, the virtual personal assistant is used in order to help the board operator or plant staff to execute tasks more effectively. So it accepts a voice command and it executes the task that the specific person is telling it to execute. And this is enabling the operator or other staff to do their task more effectively without having to go back and forth into screens and data sheets. Now, the new technologies also require new skills for the workforce of a plant. So the virtual reality, for example, requires to operate virtual reality controls. So virtual reality navigation and gaming controls, or to access hotspots that are there in the 3D graphics. The augmented reality, it requires to work with different interfaces, such as handheld devices, intelligent helmets or glasses, and to be able to work with different collaborative environments and different applications that are specific to the plant. The machine learning, it requires for the operator or the staff of the plant to access information from different sources, visualize it in different ways, assess the situation, and then make decisions with regard to the operation of the plant. Pattern recognition requires, first of all, training of the system in order to set the access authorization levels and views, but also when in the live system, the pattern recognition is using the information that it has gathered and it's set in order to allow different access levels to the staff. So basically the staff need to learn how to interface with the cameras and the smart speakers in order to train and also to use the different systems. Finally, the virtual PA, the staff need to learn how to interact with smart speakers and what commands to use in order to get the computer to execute the task. So why is the digital twin important here? Because it can enable establishing this communication between the human and the machine. So you can use the digital twin without affecting the process, the production system, to do all this training and make the operators and other staff familiar with the new features of the automated systems. So what is the need for integrating all these new technologies into the automation systems? Computers are good in data analysis, doing computations with high speed, and making recommendations based on pre-programmed recommendations that were programmed into the systems from experience of the plant staff, past experience. The human is good in recognizing in what situation he's in, rationalizing information from various sources, looking at recommendations, but taking action. So the human and the machine are working together in making correct decisions, ensuring that the operations are safe and the profitability is maintained and increased for the plant asset. And the digital twin can help to make this connection between the human and the machine to prepare the workforce to operate the plant asset. So thank you for your attention. For more information on the Emerson Digital Twin, please go to our website, emerson.com/mimic. And we're open now to take questions.
Without properly trained workforces, industrial workplaces can be deadly. According to a Gartner's report in 2018, only 20% of employees have the skills needed for their current roles. Every day, approximately 6,400 people die from occupational hazards, and human errors have been the 90% contributing factor in case of all industrial mishappenings. The best education for a human being is practice in reality, but this can be very expensive, logistically difficult, and potentially dangerous in a place like petrochemical refinery. It's time to reinvent the industrial training spaces. YOKOGAWA introduces VR-OTS, the empathetic virtual reality operator training system designed by certified Industry 4.0 professionals with years of oil and gas industry experience. This groundbreaking technology greatly shortens the learning curve of trainees with knowledge transfer rates up to 75 to 90%. They also learn 7 times faster than usual. VR OTS caters the end-to-end training needs of oil and gas refineries, upstream, downstream, power plants, pharmaceuticals, and other process plants. This is the most advanced training for operations management, maintenance, and emergency management. The moment the head-mounted VR devices are put on, trainees get teleported into the photorealistic virtual environment replicating the physical plant. Now they can start their interactive training sessions right inside the whole new immersive world without risking lives and budgets.
Now, power on feed pump B from the local switch box.
Different roles to choose from, either DCS operator, field operator, maintenance technician, or supervisor. Supports single user mode and collaborative team mode, mimicking real-life scenarios. 3 different simulation modes covering observe, train, and test. Simulations can be set to either computer-generated parameters or live IoT streaming data from the connected plant. Selection of personal protective equipment. Dynamically simulated scenarios, such as tube leak in a furnace, fire accidents, or anything you could imagine which are otherwise impossible to train in real life. Select from the list of predefined scenarios, or create your own custom scenarios and save them for later. Supervisors can monitor the current users inside the VR session and can give remote assist in real time. Very first time, the true key performance index of the trainees are measured through empirical analysis methodologies. Performance evaluation reports are generated into logical categories with easily trackable trend graphs, automatic video recording of sessions for evaluation purposes. VR OTS offers amazing results on productivity and safety, better economics with great return on investments, and saves companies from legal liabilities. Now is the time to join the 4th Industrial Revolution. VR OTS, preparing for the smart generation. Powered by YOKOGAWA Engineering Asia Private Limited. Do you still have fear of disruption or are uncertain on your VR strategies? Reach us for a free consultation. Let's do some brainstorming.
Good afternoon. Welcome to this segment that I'm going to share with you a little bit more on the immersive learning for sustainable future workforce. The agenda that I'm going to cover today, I will cover the Industry 4.0, and I'll also mention something about future of work. Then we will have the opportunity to actually check in the different perspective with regards to the future of work. And I'm going to make an analogy to bring you right from where Industry 4.0 into the immersive learning. And to end the subject, I'm going to exhibit to you some of the use cases for immersive learning and how we're going to use that for the future of work to achieve high performance workforce competency. A little bit into the backdrop of Industry 4.0, usually this is the connectivity point. We look at Industry 4.0 right back into 18th century. In the 18th century, we have Industry 1.0, and at a point in time, most of the production were achieved by mechanical means, that means powered by steam. Into Industry 2.0 in the 19th century, there was a transition from mechanical into mass production, and the prime mover actually changed from steam to labor as well as electricity. And into Industry 3.0 into 20th century, mass production actually moved on to automated production with lots of usage of electricity, electronics, as well as IT. And today, where we are today, we actually move from a situation of automated production into intelligent production, when we talk about intelligent production under Industry 4.0, we actually talk about around 8 different key technologies. 8 different key technologies for Industry 4.0. It actually has got cloud computing, big data, robotics, Internet of Things, cybersecurity, and last but not least, which is our area of discussion, is the extended reality, focusing on AR, augmented reality, VR, virtual reality, as well as mixed reality. There is a fundamental shift in terms of the technology role. In the past, we say that we actually use technology to enable business. That means if you look at the diagram on your left-hand side, technology is actually the fulcrum of that balance. It is actually playing a role to enable the business to advance. But nowadays, the situation becomes different. With the different pillars of technology that is existing, we actually come to an age where the technology becomes a business driver, which is shown on the diagram on your right-hand side. This is where we are today. We actually fundamentally use technology to transform business, to transform operational model, as well as within the transformation process, it actually gives and provide a source of competitive advantage. Therefore, fundamentally, technology has changed in terms of role of an enabler to a business driver. Let's look at the different perspective. This is the publication from Gartner itself. We take a look at the Industry 4.0 and what are the top agenda in the board of directors' mind. Based on the survey that was made and this publication in 2020, the perceived business priority for 2020 to 2021, a lot of emphasis, 53% emphasis is on digital technology to drive the business, the driver for the business. And 49%, which is the second highest priority, is about equipping workforce with the competency that is necessary to actually bring the company forward. So this is one of the perspectives that is held by Gartner, published in 2020. Let's look at another perspective, the future of work, that is published by World Economic Forum, October 20. If you look down the so-called the metrics at role level 4, you'll see the augmented reality as well as virtual reality. And vertical column, you realize that based on the survey, it will have very high impact on areas of digital communication, education, the energy sector, the health sector, as well as oil and gas. And all of them hold scores that is around 70 to 75%. And the technology is likely to be adopted by 2025 based on the sharing of all the company that is being surveyed. There's another publication that is by PwC. This is talking about the training efficacy. If we actually compare classroom training to virtual reality training, realize that virtual reality training will be 4 times, employees will complete training 4 times faster compared to classroom training. Whereas if you compare to more traditional e-learning, it's going to achieve that 1.5 times faster. And the ultimate outcome is that there will be increase in performance. The people are going to be more confident, focused, and the retention rate is going to be higher. And based on this report that is being published by PwC, it was mentioned that by 2030, almost 294 billion will contribute to the global economy by VR training, focusing on 3 important areas, that is safety training, technical training, machinery and equipment usage. We're going to illustrate that a little bit more towards the use cases. So let's look at something that's very traditional. This is the learning pyramid itself. Right on top, you actually have the traditional teaching methods, which range from lectures to reading to audio visual. All right. At this point in time, we will classify that as a more passive kind of teaching methods. Right at the bottom of that learning pyramid, we have the more cooperative learning methods. All right. And basically, I wanted to say that that learning pedagogy is basically equivalent to group discussion, practice by doing it, and actually teaching other people how to use or how to teach, how to actually use a certain equipment. And if you base on the knowledge retention itself, almost 75 to 90% of this is being retained. And that is the basis of immersive learning. That means we go through a learning pedagogy of I do, you see. That means the avatar is doing it and you are looking at how the avatar is doing it. The second step that involved is the so-called the training mode, which is I guide, you do. That means now I guide and you will be the one who will be doing it. And the third step of it is the final phase, that is you do, I command. That means the person, you will be physically doing the job and you are able to make comments on the outcome of his learning. So that is the very basis of the AR/VR knowledge retention model. Before we proceed further, there is something also very significant in the Industry 4.0. This is a book that is being published by, it's called The Critical Path. It's published by a futurist, inventor, Mr. Buckminster Fuller. At a point in 1900, knowledge is doubled every century. Right down to 1945, he realized that knowledge is doubling every 25 years. At the point where the book is written, 1982, knowledge is doubling every 12 to 13 months. That means every year knowledge is being renewed. New knowledge comes on board. In 2020, IBM actually predicted knowledge doubling every 12 hours. That means every day knowledge is being produced, new knowledge is being produced. Right? So under this kind of situation, how do we actually grasp the exponential growth of knowledge? How we can actually cope up with that? And how we can actually use immersive technology to address those new area of knowledge and to input that into the future workforce to gain productivity, competency, all right? I want to use the analogy of a car. Right? You see a road and a car, right? When we actually wanted to drive a car, the first thing that we do is to look at the front mirror, through the windshield. We look at the front mirror, and did you actually see a well-constructed road in front of you? Do you see safety on the road? You see safety signboard, traffic light, so on and so forth. You see the road in front that's been cleared, and other infrastructure already been constructed for the car to move safely forward. Well, when we talk about looking at the windscreen, through the windscreen, looking forward, it is actually the government vision, all right? In each of the country, government actually took a very bold step forward to encourage enterprise to actually get into Industry 4.0. In this particular slide, you see, for example, in Singapore, we have the SIRI framework. SIRI means Smart Industry Readiness Index framework. It's actually a very broad ecosystem based on Smart Nation initiative, and all encouraging to all the enterprise to adopt Industry 4.0. In Japan, we have Society 5.0, China Make in China 2025, Germany, Platform Industry 4.0, United States, Advanced Manufacturing, and other local initiatives around ASEAN area, like Thailand 4.0, Vietnam 4.0, and India Make in India. See, these are the so-called the efforts that's been put up by the government to actually pave the path, put in the infrastructure so that we can actually bring and guide the so-called enterprise, the company, to actually adopt that Industry 4.0 in a more rapid way. And within those initiatives itself, what is being discovered is that key observation on the challenges faced by the company, people are a little bit hesitant to move into it because there is a lack of familiarity with the Industry 4.0 concept. It is also unclear how to get started. And most important point is that out of so many kind of initiative, right, how do you actually identify the genuine weak area? How can you actually develop the KPI or the return in investment to compute for the return investment should you get into those areas? And also at the same time, an integrated and more forward-looking L&D program to allow the current workforce to get into Industry 4.0. So those are the key observations faced by the different government, and is actually summarized in this particular slides. So this is looking forward. That means when you look forward, yes, the government has initiative, has done some infrastructure for you to actually get into that. But then if you look, when you want to drive the car, important point is that in order for us to drive safely, you have to look at the rear mirror. The rear mirror, basically, we talk about what are the resources available for us in the future to drive such initiative. I want to show you this rear mirror by using the education sector. We call it the reverse mentoring process. What essentially this means is that if you to look at a situation, for example, in Singapore, right down to the elementary school, or we call it the primary school, these are actually screenshots of tender processes that was launched within the last few months. This is something that is being launched by Ministry of Home Affairs in Singapore. And what they wanted to do is to design, develop, and produce augmented reality targeted at primary school. And that it closes on the 5th of November 2020. Another situation is that another different primary school, they wanted to develop mixed reality experience for heritage wall. Another example at a higher level, secondary school level, is that VR creation, using VR to teach science lessons. This is at the higher level, we call it the Institute of Technical Education. They are actually asking vendors to provide mixed reality training for people to, assessment system for people to work at height, and how to train people to work at height, and how to develop that competency. This is another tender that was published last year, the Nanyang Polytechnic. They are looking for welding simulator. That means we actually teach the students how to do welding, different position in terms of welding, different material for welding. This is another tender, right, that is looking for AR, VR headsets. And the last one that I'm going to show you is that to supply and install a complete 3D virtual reality computational flow dynamics. See, the education sector, I'm sure that this has been done for many of the countries. This is just an example that I pick up for Singapore. A lot of this immersive learning is being factored into the learning curriculum, right down from elementary school to the technical colleges. For example, for this particular case, the people who graduate 1 or 2 years later will be actually moving into the workforce. When they are into the workforce, they actually bring this rich experience that they have already experienced what is immersive learning. And technology to them is something that will not be something that's new. When you actually put together the existing workforce together with these people who are out from the school, then the more senior people can share their experience about the work scope, the work processes, and these younger people are ready to suggest to them how this can be enabled by the so-called the immersive learning. Therefore, traditionally we call it mentoring process or coaching process. Nowadays, with Industry 4.0, the popular term that comes on board is actually the reverse mentoring. That means when you pair people, the younger people are able to do a reverse mentoring in the area of immersive technology that they are exposed to when they are in the learning institution. So that's a back mirror. Earlier on, we spoke about this exponential learning knowledge to be gained. That means every day there are new knowledge to be gained. To be exposed to those knowledge, it takes a lot of effort. If you look at the community, the so-called immersive learning community, you realize that people has get together, all right, and they form groups, all right. These are actually snapshot of Facebook group. For example, right on the top right hand side, top right hand corner, we have the virtual reality, a public group of 54,000 members. Every day, you can see people sharing about what they have done, right? What are the blind spots of the project they have got into? What are the difficulty in running some of the project? What are some of the success they have done in terms of certain industry, certain category? Nowadays, people are more ready to share because through sharing in a group itself, you can actually gain a lot of so-called insight into other people's project itself. Therefore, with Industry 4.0, everybody realized that they cannot be on their own. They have to be working in a team. And this community is growing every day. It ranges from virtual reality to augmented reality to AR, VR testing, to Microsoft HoloLens mixed reality, and so on and so forth. People are more willing to share. People are willing to learn together because only by learning together, they are able to cope up with the exponential growth in terms of knowledge that is been changing every day, right? So that is the side mirror of the car when you move forward. So let's come back into this subject where we are in the pandemic itself, the key requirements for business continuity. The major ones are social distancing, contingency plan, cross-training, as well as remote collaboration. Let's look at what can be achieved by extended reality, right? VR, or virtual reality, augmented reality, as well as mixed reality. Through the application of immersive learning, you are able to actually get into most of this, right, without difficulty. And most of those areas that like social distancing can be actually resolved. Learning can be done when people are apart, all right? So let's look at some of the example, all right? Let's start with virtual reality. What you can see is that somebody with a head-mounted device, Oculus head-mounted device, when he actually looks into the head-mounted device, this is what he sees through the eyepiece, and he immediately get transported to a fully immersive virtual environment, which is exactly like his workplace. I wanted to go through a 3-steps learning pedagogy so that you can understand even this 3-step learning pedagogy can be implemented whether you are in virtual reality, augmented reality, as well as mixed reality. All right, those 3 steps are observation mode, training mode, and testing mode. Observation mode basically says that I do, you see. You can see an avatar doing the job. You can hear what he wants to explain to you, all the different instruction. And you move on to training mode is that next portion of it is that I coach you do, all right, I guide you do, which is a training mode. That means you are now required to do the job, but I'm going to guide you through. And finally, the testing mode is involving so-called a process of you do, I give the final comment. Let's look at that. So this is an observation mode. Exactly what you see is that I do, you see. The avatar is actually doing it. So the entire process is mapped out. Before he does a certain job, he is actually communicating with his team worker. This is a 3-step process. First of all, he turn off a certain part. It's a pump switch over. he turned off certain part of the process, all right? Then the next step is that he's going to the local panel to power off a certain part of the other process, for example, switch from pump A to pump B. And finally, he went to open that valve for pump B. So every step is being illustrated. For example, if I'm a trainee, I'll be going through this process with them, all right? But if there is a certain what if condition, if there's a fire, what would you do? What kind of fire extinguisher would you use? If it's due to chemical, if it's due to any other, for example, fire, electricity. So this can be explained by watching the avatar doing it and hearing his explanation for that. So this is the first step of the learning pedagogy, which is the observation mode. So now we come into the training mode. The training mode, let's go through a few examples of the training mode.
The following PPE.
PPE selection.
Helmet, leather gloves, safety shoes, safety goggles, flame retardant coverall, earplugs, earmuffs.
See, before somebody gets into to the site to do a certain job, it is important that he chose the right PPE. Therefore, this PPE selection and the type of PPE is customized to that particular plant. Alright. So this is part of the training. He has to get the PPE correct. Otherwise, it is a violation of industrial safety. Next is that environmental familiarization. Let's say if he's in charge of certain area, certain zone and all that, before he can do operation or maintenance work, he has to be fully so-called familiar with the environment that he's been assigned to. So this is a segment on that. So through immersive learning, he's able to get into every single part of the plant without physically doing it. And you're able to hear the background scenery, voice, noise behind there to simulate the actual learning environment. So environmental familiarization is one. In the past, as long as one can achieve production with safety, that's good enough. But these days, you have to achieve much more. You have to achieve profitability. You have to achieve energy saving. And also at the same time, you also have to worry about asset reliability. In order to understand asset reliability is that most of the equipment operates within a certain range, which we call it the operational range. If you drive them beyond those range, then the equipment will break down early, right? So what you can see over here is that you can see the X-ray version of the equipment so that people can understand how the mechanical parts are moving when they actually switch on the certain machine. Through this X-ray vision, you can actually imagine how the mechanical parts are actually moving, all right? And usually it is this mechanical parts that is the one that breaks down early if it's used for a couple of years. Next is the safety in hands-on practice. Let's look at that.
Open fuel oil valve V1. Open atomizing steam valve V2.
So you can actually achieve hands-on learning in a fully immersive environment. Let's look at a different type of environment, okay? Partial immersive environment, okay? If you do not have in a fully immersive environment, you can always do that on a tablet, like this particular case that we are actually using web-based VR. You can also do environmental familiarization as you are able to get into every part of the plant, the areas that you are actually taking care of. That through a tablet, you can get yourself familiarized with all the different parts of the plant where you're supposed to do the operation as well as the maintenance. So this is environmental familiarization under a partially immersive situation, which can be achieved by using a tablet. On and off, you need to do maintenance work. And I want to illustrate this safety operation as well as maintenance training using a euphoria-based AR use case, all right? Using what we call it is a model tracking. As you see, you can actually see a physical machine, all right? And that physical machine has got some trouble, and the steps are being given, all right? Alert condition is being detected. Something that you have to actually look at it. Step number 2, you have to actually look at the interior of this, but you have to actually do a list of so-called health and safety checklists, whether the blower case becomes hot, internal rotating part may cause injury. You have to examine things like pneumatic pressure risk, at least 2.0, or the so-called you do not stand in front of the blower, it may cause bodily harm. So upon achieving that, you have to start your repair process, all right? So the repair process, first of all, you have to disassemble, all right? That means you have to take out all the different parts. So this is playing the disassembly repair process. And once things are being disassembled, you can actually remove that part that is being faulty and replace it with a new part. So upon doing that, that means you have already replaced the parts, then you have to assemble, okay? And that's the end of this, all right? So that can be achieved by so-called AR, which can be actually done using a mobile phone. And I want to illustrate a different use case. You know, most of the time we talk about remote collaboration. That means if we are having difficulty with some equipment within the company itself, within the plant itself, and the remote expert is somewhere else, and you need to actually connect with the remote expert to actually to solve that problem that you're facing in a plant itself. So I basically use a mixed reality remote assistant, Microsoft Dynamics 365. Let's look at this. And I illustrate this by using an oscilloscope. This is a part where on-site technician calls on remote expert, and remote expert actually use the mobile phone to annotate area that he is supposed to take care, he's supposed to be done. And he actually physically adjusts at the machine. In this case, it's an oscilloscope. And the entire view is achieved looking through a Microsoft HoloLens. So I wanted to summarize again, whether you have it on AR, VR, or mixed reality, the important point is that you have to learn through a learning pedagogy, a more structured, systematic way of learning, which involve observation mode, that is I do, you see. Avatar is doing it and you see it, all right? The training mode is that now you'll guide through a voice guidance that you'll do the actual job. That means you do the job by yourself. And the third step is the testing mode where you actually get the audit result. That means you do, and I give a final comment on how you are doing it. So this is the three-step learning pedagogy. And before we end, look at the future of work. It is actually at the top of the HR leader's mind. Again, this is a Gartner's publication. You actually look at future of work, and most important point is the critical skills and competency development, which gathered 66%. All right, and through that, I want to mention the last portion, that is the 3 growth strategy on immersive learning, which involve a short term, medium term, as well as a longer term. All right, what is important is that we need to discover, we need to find out what is available in the market, what is available for your kind of industry. You need to evaluate, we need to evaluate which is good for your company itself for this kind of skill sets training before you implement it. But important point is that when you implement it, it is important to measure. Once you do the measurement, you may need to refine it again. And important point is that the progress may take a bit of time, but then it is slow progress is better than no progress. Therefore, stay positive and don't give up. Immersive learning for the future of work is the way forward. And with that, I'd like to thank you for your attention. And I'm basically from Yokogawa. I'm actually taking care of the Industry 4.0, particularly focusing in the area of immersive learning. And if you're happy, you can actually connect with me on LinkedIn itself. And with that, I thank you for your attention. Thank you so much. Cheers.
We've got a very good panel today representing 4 different companies. Have Michael from L3 Harris, Han from Yokogawa, Pablo from Technaton, and Alex from Siemens. And this is a panel discussion around based around simulation, and we're going to start with I'll start off with questions on topics, and then let's see how the discussion goes through the panel. I believe the webinar itself is going to be recorded, so you will be able to have this and maybe share it with some colleagues later on. So I guess we've all been experiencing some difficult and challenging times recently, and I don't know about you, but all our business conversations seem to start around this, and often we move away, come back to the subject matter, and then address it again. So I'd like to start with these new challenges in that simulation as a business has had to address these topics. So we must be gathering some learnings, positives, negatives. And I'd like to ask the panel if they can address this point, and maybe we can start with Pablo here.
Okay, thank you, Nigel. Well, first, I hope that all of you and your families find well, fighting together against this virus and this situation. And it's a pleasure for me, of course, to participate in this session with new format and adapted to the current times, and trying to contribute to keep our industry engaged in this evolving situation. Okay. Well, it's well known that the spread of the coronavirus, okay, has impacted the business all over the world because of travel restrictions, population lockdowns, investment shutoffs, and, well, administrations slow down. And simulation business, of course, has been affected as well in different aspects and different consequences. From the new business perspective, the pandemic has led companies to shutoffs, investment shutoffs, and has stopped most of the non-essential projects that were about to get launched. So the new business is a little bit stopped. Additionally, other priorities become higher, and all the efforts are focused on that. But I would like to make the reflection based on the ongoing projects. Okay? This pandemic situation has led companies to a rapid shift of a rapid movement of working from home and relying on remote work tools, and more than ever, in this sense, telework makes it essential. At Technaton, telework was a common practice. We have decentralized maintenance schemes in our simulation fleet. Okay, we have several simulators with our headquarters in Madrid, and we are quite used to working remote. But really, it was a big challenge to move all our employees to work at home in one day. I have to say that thanks to our preparedness, the incredible support from the IT organization, and the model response of our employees, we got a minimal impact in our operations, and most of the simulation projects at Technaton did not stop, continuing with the development of these projects remotely. Logically, the project has been affected in a different grade, depending on the nature of the project and the necessary presence in the plant for these projects. As an example, we were working in France in the EDF simulators when the confinement started, and due to the plant policies, we need to stop all the work and go back to Spain with difficulties to move across the borders. Fortunately, I have to say that yesterday we resumed the work in France, and hopefully we will complete the work in a couple of weeks. But I think that one of the main things that we have faced during this stage is the testing, the simulator testing itself. Okay, I think it's a particularly interesting point, how simulators can be tested remotely and jointly with the client. Okay? Here, the communication applications are playing a critical role, but they allow the collaboration between the team members. Okay? During this period, we have some experiences in this matter where projects affected by mobility limitations lead us to look for new schemes for factory acceptance test and pre-site acceptance test. And I will comment a couple of examples. The first one was the GES21 simulator. This is a simulator for non-mainland power plant simulator in an isolated electrical system. And the project was in the pre-SAT test phase. We faced this with the simulator team without remote connection through a secure VPN network. And the thing, the customer can operate the software from their home as well, using the normal tools like Teams or Skype type communications. We can give the control to the customer, and they can perform the test by themselves. You can see here in this slide in the upper right corner, one of our engineers testing the simulator with the customer from home. Okay. Another different case is, well, we are involved in an Ovation DCS upgrade in the YOKOGAWA simulator in Brazil. And we are in a special testing process. Okay, here the problem is a little bit more complicated because it involves people from different countries. It involves people from Brazil, from the US, and from Spain. And we don't want to stop the project. So the FAT test that is going to be executed in the next months, okay, was planned to be executed in Canberra Town in the US. But now we are going to attend this test remotely, supported by the video cameras and VPN connection. Okay. And some part of these tests are going to be executed in Spain with the presence of our customer for electronuclear using the same configuration. With this approach, we hope not to delay the project. Unfortunately, we don't know at the present what is going to happen because the installation of the plant is planned by the end of the summer. And well, we'll see how the situation evolves in Brazil. I think that, well, these experiences demonstrate us that the current technology allow us to continue working remote simulation projects. And even more, we need that we think to design, we need to think and redesign the processes. Okay, that can lead, this can lead us to reduce commissioning time and increase the overall process efficiency. However, of course, there is a negative side that will lose the human side and is affected for the loss of the proximity with our colleagues and with the clients that always contribute to the better execution of the projects. But I think that we have a good communication system to keep a continued contact with our customers and our peers. So is what I recommend always, to use cameras as much as we can. At least we can see our faces. Okay. And well, this reflection is made mostly applicable to the development process of the simulator, but of course, from the final user perspective, and particularly from the training perspective, it's also clear that simulation in cloud or virtual reality are going to play a relevant role in the near future.
Yeah, that's good, and it's good to hear, especially your industry. Your kind of simulation is has to be because of the containment in nuclear plant. But you know, the same in oil and gas with hydrocarbon areas, and I think some of the work processes are what needs to be addressed here for simulation. Pablo, you say that you've had really positive effects by people who are working remotely, where remote is their home office or their home and not the company location. So how maybe Han, you can say something. Being able to put some measurability on training simulation from a distance, especially those people who are normally on the plants. Well, could you give us some of your experiences, Han?
Okay, thank you, Nigel. If you take a look at the slide, actually, I'm going to talk a little bit on the simulation in the cloud as well as distance learning for today's environment. Today's environment is we are still in the pandemic situation. I'm just going to tell you a story. Just a month ago, I was in this McDonald's, and I saw a group of 14 to 16 years old kids in school uniform. They were completely engrossed in their mobile phones. And I was telling myself, that is a group of people in the next 10 years, they will be working in a plant. And a survey has found out that these millennials people spend a lot of time with their gaming. They learn through the games as well. Even recently, I read a book that is by Mark Prensky. In his book that is titled Digital Game-Based Learning. He highlighted certain differences between older generation like us with the younger generation. They say that one of the significant things that I can think about in the book is that these young people, they think about technology as a friend, whereas when we have some new technology, we say, it's going to take some time and all that. No? And not only that, but they wanted to have, when they actually play games, they wanted to have connectivity. They wanted to be connected as a team. That's where they derive fun as well as the exchange information. Compared to people like us, we prefer to have standalone. So if we were to take this situation into what we are experiencing now, called COVID situation, learning can happen in the home as long as you have open access to material like YouTube videos and all that. That would do. But then the question is that how do you know that employees are benefiting from this kind of activity? Are you able to monitor progress or to get any objective feedback from here? Therefore, within the so-called cloud-based kind of learning, especially distance learning, there are 4 things that we have to put in place. That is, the self-paced element has to be there. It actually forms the measurement of the learning, even without the instructor that is being present there. Second point is that the lessons in terms of learning outcome has to be clearly defined. And third item is that people tend to want to study anytime, any place, especially now with social distancing. They can just pick out the mobile and start studying. And the last point is that, for cloud access, when you get into a simulation itself, the trainees can be in different geographical location, but then the instructor can be at a different location, but at any time, he can access to this simulation model and tell the trainees that whether he's on the right track or in the wrong track. So these are things that we need to put in place, plus the gaming construction of this distance learning module. So some critical thinking kind of exercises has to be there. Something like how to do monitoring, how to do troubleshooting, diagnosis, response, procedure planning, sequencing like startup, shutdown, prediction, observation to confirm prediction and all that. This has to be put in place. So one of the very robust infrastructure is actually the cloud learning as software as a service. With this delivery platform is very intuitive because a few things it can actually it's very easy to deploy, and it has low infrastructure costs and low maintenance costs and upgrade costs. So nowadays you can actually technicians or operators from the industry itself, they can actually find generic simulator modules from focusing on refinery, upstream, chemical, unit operation, as well as process fundamental. Therefore, they can actually do the learning and play the games, and this becomes very effective. And especially now when they're at home, this is becoming very invaluable simulation tool for them. So that is my view on that.
Yeah, great view. I particularly relate to the younger people because my youngest grandson, he's 3 years of age, and I caught him trying to do this to open the car window from his baby seat. So it's we know how younger people work these days. Nice. But Alex, I think that what we're talking about here is when we're talking about the people who bring the traditional methods with all of the experience, it's valuable still, but the industry moves so quickly now that it's not possible to wait for the younger qualified people to get that experience. They have the likes of Google and other means to find that experience. So simulation as a subset of this overall digital transformation for operating plants, keeping them available. What are the most important requirements that operators need to address?
Yeah, fair question. First of all, Nigel, good luck for you that your youngest son or kid hasn't tried to use the hammer to open the window. That is the old-fashioned way. Open a window with the hammer. So lucky you that he was a young guy, tried to stretch it. So no, but coming back to your question, I mean, it's really interesting. And what Han just said is, I think it's so important that digitalization and that the digital transformation is taking place also in the process industry. I mean, we are not well known as the leading guys in going for innovations, pushing the transformation quickly forward. And as Hans said, our kids are playing Minecraft, Fortnite, whatever, FIFA soccer around the world together. During the days and nights, they have high performance. It's not a question of performance, it's just there. They can talk, they can use the high graphics, high definition graphics. It's just playing around, talking to each other around the globe. So in our private life, and the younger people are used to it as it is a normal thing. And in the industry, we have to go forward with the digital transformation, from my personal belief, especially here in Germany, even faster. So we really have to accelerate. And from the part of your question, what are the requirements important, what owner operators needs to address? I think first for simulation, we have to have a lot of information. We have to have know-how, we have to have data. And my strong observation is that we have to bring these, what we call in Siemens, the dark data stuff. Yeah, we know we have the data available. We do not know really where they are, how to access them. Are they accessible in this special situation where we are working from home? So we have to bring data together in a context that we call it the digital twin. And based on this twin and contextualized data, that we can do different simulation aspects. So we just heard about training simulation. We also go for, and later on maybe we will touch the simulation of construction sites. So how to simulate the commissioning of a DCS system, and that we really get, let's say, let's summarize it as meaningful insights of our plants, so that we have the real important things at hand, simulate different scenarios and learn from it. And for me, the most important thing is to support our people in the plant itself to really go for the right decisions in time, based on really valid information. So the prerequisites is really use the information you have at hand, bring them together, contextualize them, and then go for your different simulation scenarios. We may touch during this panel discussion here, but I think this is something we really have to focus on. We have enough data, we have the know-how, but we really have to start better today than tomorrow to bring these data together, contextualize them, and make really intelligent and smart decisions based on this.
Yeah, that's good. That's good. I think the part about having these insights and learning without loss, where loss can be injury to personnel, it can be loss of availability and production of the plant, it can be loss of trust in your own company here. So this kind of it typifies what simulation is, not do it at a consequence to any operator or the company or the plant. So
yeah, and simulation nowadays, Nigel, if I may add this, it's not, let's say, based on one information silo itself. So the simulation is getting more complex because we have more data, more information available. And I would like to compare it. Just the idea came me a couple of weeks ago. If we compare this to the weather forecast, what we right now do day by day, and we do not only forecast if it's cloudy or sunny, we do meanwhile forecast a week ago upfront where do we have the storm impact. What about the rain period in the summertime in Germany? So starting to collect data 100 years ago, everybody on his own. Today we share this information on a global scale. So we simulate on a totally different data platform, data twin platform, if you like to say. And so the value we get out of this connected data, this is absolutely much more higher than years or decades before. And that is, I think, we can learn from in the process industry. We have a lot of know-how. We have all this experienced people, but we have to bring it together, simulate scenarios, and learn from it. And I think simulation can benefit so much from this digital transformation, maybe as nothing else. So that's my strong belief.
Yeah, that's good. And yeah, it might sound a little bit strange about the weather forecast, but when you look at some of the plants which are in the Middle East, where you have 50, 60 degrees temperatures, you need to know when it's going to be so hot. You need to know when there's a sandstorm coming, and you need to look at the impact it has on the planned work ahead, and
exactly.
take decisions around that. And talking about technology here, Michael, I know that L3 Harris has been promoting the use of a graphical model building for a long time, perhaps pioneering this. So why did L3 Harris go in that direction, and you know, what results have you seen from that?
Thanks, Nigel. That's right. In the late 1980s, we had already realized that graphical object-based simulation would do a number of things for us if we could get it right. Well, the first one was to make our process simulations more consistent, as a number of people work on these projects, and that we would shorten our project development cycles, and that we would have standardized libraries as we went from one project to the next. And ultimately, we would be making model maintenance and upgrades easier for our customers. In 1991, we released what was then known as ROSE, and is today known as Orchid Modeling Environment. At first, the market didn't believe that a graphical simulation environment could replace hand coding. You know, people get entrenched. That was the view of the day. But sure enough, we very quickly became the leader in the field, and customers worldwide came to trust our left field innovation. We invested a lot in this initial deployment, and we continue to invest in this crown jewel today. We're convinced that it's robust and the best integrated modeling tool in the market. You know, it's not just our conviction. A number of customers that have been exposed to competing products really like our platform. But Nigel, more than a model building tool, it's also a runtime environment. And as you can see on the screen, it's a runtime environment for plant system models during development, for testing individual plant systems, coupled systems, and the whole plant simulator. Our customers use the same environment that we do. We also have certain customers that are using the environment to fully develop their own plant models, and very successfully. So what did it do for us? It put us on the map. Before we released the product, we were just another vendor, mostly known for making Canadian can-do plant simulators. Our international market presence grew really fast after we released this product.
Yeah, it's. I think it's very much of a requirement. Again, looking at the learning without any loss, you can see what the optimal process simulation is to move forward with, whether that's sort of startup of a plant, initial startup, or after a campaign.
I should, sorry, Nigel, I should add, Alex mentioned the intensity or the amount of data that is required for good simulations. That is absolutely correct. We deal with a lot of data. And this environment that we're talking about, we do not just model the data that we receive. We link all of that data to the models themselves. So there's continuity. There's always a way to see where we are data to simulation and vice versa.
Yeah. So if you take all of that and then you bring the actual human resource into here, then collaboration and accountability are the critical elements for teamwork, especially in site operating procedures such as tag out, lockout, and other simulations. But Han, the collaboration performance between a panel operator, like in a control room environment, and the field operator, like monitoring, measuring, tracking simulated scenarios. You're doing a lot of that. I mean, I can see from the image here, you bring in the control room and the field work it together.
Yes, we do a lot in that. I want to stress about between the panel operator as well as the field operator. They are basically governed by two different areas, what we call it the accountability part. That means if you are to train field operator, whatever you build in the field itself, it must be capable of accounting for the final learning as well as the testing outcome. That means there must be a KPI to it, as well as the collaboration between panel as well as field operator, including the instructor. There must be a collaboration in terms of a dialogue. What we usually do, if you look at the field site, right at the bottom there, the virtual reality, VR actually stands for virtual reality. And yeah, usually in terms of our learning pedagogy, which we prescribe for the customers, it has got to get three different modes. The first, it is like a coaching process. The first mode, we call it the observation mode. Basically, it is I do, you see. That means when somebody actually put on the Oculus itself right in the field, he is able to see an avatar doing the job, the entire process, with the avatar explaining why he has to do this, next step, what he needs to do, all right? So it's an observation mode, which I call I do, you see. The second mode that we actually take them through that accountability is that I guide, you do. That means it's a training mode. Now the avatar disappears, and we actually give them the instruction and tell them the location so that they know at this particular location, they're supposed to turn on the valve, and next location, the panel, they're going to switch on something. And finally, the testing mode, or there's nothing to guide them, he's supposed to do the entire process by himself. So the entire KPI that's being captured is like whether he's familiar with the usage of the PPE, whether within the SOP itself, he has adhered to the time, the site equipment layout, whether he's familiar, and the SOP sequence, whether he knows how to use the different tools, and that gets the overall results. On the OTS side, if you look, we call it the operator training simulator, which is the central control room side. It is setting up the scenario. So according to the standard operating procedures, events occurring in the ODS is managed by the panel operator and trigger the field operator to perform certain activity in the field using the VR mounted device. So this is a collaboration we talk about. So when the field operator is out in the field, the same ODS equipment condition will be mirrored there. Once the field operator has completed the task, for example, let's say he closes the valve, that status of being closed at the valve will be reflected into the OTS. So there's a process data exchange between the OTS system as well as the VR system in a very dynamic way. The instructor is able to monitor the field and panel operator via a PC monitor. In the actual case, the process operation supervisor will actually use his PC to monitor the DCS graphics for process control and the CCTV for field operation. So what I want to summarize is that the overall evaluation report will have the scores of the sequence of SOP steps performed by the trainee. And based on the report, supervisor can actually talk to the trainee and explain the mistakes they have done, the reason for the mistakes. This will enable them to explain. So there is a collaboration now between the instructor, the field operator, as well as the panel operator. So this is the skill-based competency training simulator module that we usually construct for our client.
Yeah, very good. And this particular area of simulation is very close to my heart of interest and things which I'm focused on a day-to-day. I look forward to having some separate discussions, Han, with you about this topic and sharing some experiences.
Right, thank you.
Yeah, you know, when we come to simulation here and this type of interoperability, Alex, we've heard about bringing the control room technician together with the field worker. What about other areas of simulation that can give benefits?
That's a fair question. We just heard about process simulations, which is, I think, really important stuff during the feed engineering phase. If we design plans and then try to optimize them, if it is efficiency, the costing, all the impacts we have to have in mind. We have heard about training simulators, the OTS, ITS stuff. So everything is important. And give another example. So we have a customer at the moment. We're serving them. They are 2 months late in the commissioning time and phase, and we have supported them in doing the operators training, 60 operators trained in a virtual classroom. We bring them together in these days so that we really shrink the time of delay for going live with this tank farm. And then I agree with Hans. These are the things where we can immediately cloud-based offering services and benefits to our customers. They don't have to go for an own setup of a classroom, of a virtual classroom. We can train the people during these times when they are in the home office, so we can do all these training simulations in a gaming mode. But they are prepared. If they enter the first time the plant, they know what they will touch. They know the behavior. They know the difficult and different scenarios. I would like to compare the situation, as it is still not let's say a no-brainer in our industry. I don't know if you guys agree, but training simulation, all these different training varieties is still something. Some are going for it. Some say, well, it's no for the major capital projects. But I think if you compare the training simulation with what other companies and other industries are doing, meanwhile, since years and decades, I think we can also do more in the process industries. If you go to and we were just starting our chats in front of the meeting here, talking about the airlines. They do the training simulators since, I don't know, 20, 30, 40 years. Every pilot has to pass a training every 3 months in a training simulator, pass these immersive trainings and then special situations, get trained really every quarter in these simulators. I think we can learn also from other industries to transfer it into our industry and make it a common thing, that we really use this new technology to be better prepared, to avoid incidents, to really save the lives of our employees. That is one thing, but there's another thing you can see on this slide here. So that we strongly believe during engineering phase for automation systems, for example, that you can also simulate the commissioning of DCS systems, that during operating a plant, and let's say, as an example, your compressor station is going down, the system should support our operators in simulating different scenarios. Okay, scenario 1 is shutting down the plant. Maybe that's the worst one. Scenario 2 can be, okay, based on the ongoing processes, there is a solution. You can limit the production to 70%, but you can run the plant, and you can look for a maintenance window to repair the compressor station, and then start to upgrade your plant capacity to again 100%. Or maybe scenario C is, based on the SAP information we get, so collecting data and contextualizing not only in the technical area, but from the commercials as well. SAP is telling me, well, we can't sell other products at the moment we are producing. So it's easily to go down to a 50% run case, so that you have enough time to repair the compressor station, to do a regulated maintenance job and really do it in a calculated way and safe way. But you do not, let's say, infect your operations in a bad way, or you go for energy waste, or you lower the quality of your production. So the interoperability, Nigel, as you have said, is for me the key. Not, let's say, only to concentrate on one thing, but bringing different disciplines together, different, let's say, scenarios together. And that is where I think we can benefit a lot from simulation. So gathering data from SAP, from our DCS systems, bringing engineering information into it, and then, let's say, offering our operators a solid foundation for decision-making processes. As said, to have the cost control available, to have the safety in mind, which is always key, that we do our decision based on safety first. That is an important thing. Simulation can support us. And if you have a look to this closed circle in this picture, it starts from the engineering phase during commissioning, and then let's say go for the operations, and then dismantling the plant or shutting it down. So if we bring these things together with intelligent ways and digitalization, then I think the industry and ourselves, we can benefit a lot from different ways how to simulate our activities, plant operations. So that is my personal view and the view of Siemens in this case. Nigel, what I have to add here?
Yeah, really good points there. And like plant optimization, environmental factors to take into consideration.
But just can add one thing. I had a chat with a super major EPC, and he's serving a lot of operators, challenging him. And he said, "Well, Alex, if you can really offer us to simulate against the digital twin from engineering, so simulate the operations, the really live data against this digital engineering twin, that would be beneficial for us. That we have these data 1D, 2D, 3D available, and simulate it against the real existing situation in the plant. This would be beneficial for our decision-making process in operating remote plants where we do not even have people on site. So it's all about cost savings in this manner as well. I guess my colleagues here, they have all this impact from the market, unmanned operations, reduction of on-site time, all these things where we can save cost, higher safety, and all these issues. I think that is an impact where we in this area here can help our customers, to increase, let's say, all these things, safety, efficiency, and being more and better prepared for the things we have to solve.
Yeah, and you touched on earlier about how we in Siemens refer to dark data. It used to be dark data, and then these people through education called data scientists came along and said, I can show you what your data looks like here. So very, very important, and again, a new value of how the combination of the data, the available data, and the science can benefit, or simulation can benefit there. But let's still talk about people here that I recall from the first SIMWORDS seminar that Michael, you mentioned about your Orchid IX environment for 3D immersion. How's that going?
Well, let me tell you, and for since there wasn't large introductions at the beginning of this, and I need to set a bit of a background for this. The background is for those that don't know, I'm actually calling in from Montreal, and the division of L3 Harris in Montreal does a number of different things serving different markets, and those markets are naval power generation and the space sector. And the space business was really sort of our entry into virtual reality. We've been at it for more than 20 years. Before there were gaming engines as we know them today. And our long-term VR work was mostly for the International Space Station. When astronauts and cosmonauts go to the space station to work with the complex mobile arms on the station, they first go to our so-called MOT simulator at the Canadian Space Agency in St. Hubert, Quebec, which is not far from where I am now. In the real ISS, the astronauts can look outside using cameras so that they can see what they're doing. On the simulator, see outside means looking at a synthetic environment where we can see not only the arms, but space itself, and including beautiful views of Earth. Excuse me. So we've done VR work in our business, in our other businesses as well. But in late 2018 and in early 2019, two things happened. First, we wanted a bigger presence in the world of extended reality. And we initially had our sights on simulating a full nuclear power plant. We competed against others that were already entrenched in this business for a first-of-a-kind 3D project that included a large nuclear power plant with the full plant 3D model, radiation detection in the 3D facility, integration with the customer's OTS, integration with two-dimensional PNID drawings, and much more. It's a very interesting project. But the short of it is we won. And we chose Unity as the engine for that project, and it's in an advanced state now. And I see this as a stepping stone towards being able to deploy true digital twins. But something else happened. We met a startup company in Montreal called Imagine 4D. They were starting to commercialize a new technology that was just amazing. And that's what you're seeing in the picture there. People could go into an environment and feel immersed with full depth perception without putting on headsets. I'm not exaggerating. You've got to see this. We immediately saw the applications for our business domains, and we wanted to get in on the action early. So we teamed up with them, and our version of the product, as you see, is called Orchid IX. It's truly unique. It uses curved mirrors, Nigel, and special software that allows people to collaborate in the same 3D virtual world. Think of it this way. Think of it as the world's largest VR headset.
Yeah.
Other large display systems, things that you've heard of like caves, igloos, power walls, all require headsets to be worn if you want to have any sense of 3D immersion. And we refer to these as direct projection systems. We are offering high-value asset customers a way to see and interact with their synthetic plants with high accuracy, to receive other data from their plants, and teams of people can now work together with the content, and I would argue, equally as importantly, with each other, like in the real world.
Yeah.
So
I have,
yeah, go ahead.
I was going to say, I also have an experience of one customer who has this environment deployed on their site, and mandatory, their maintenance team, fully equipped to go onto the plant with ear protectors, with sound in the environment to de-risk any human incident or accident, because statistically, the first 30 minutes when an individual goes onto the plant is the highest probability of any incident or accident.
That's right.
So I definitely think there is a space for this in all simulation and preparation for plant visits, whether it's at a management level or whether it's at a technician level.
Yeah. And I want to add, you mentioned sound. This thing is equipped with a 7-channel sound system. So you do also experience the sounds from the environment. And the high accuracy content that can be enabled inside of the environment can be done in many ways, whether we develop it or whether we repurpose 3D content that customers or partners have already invested in. We are easily work with Unity, Unreal, Unigen, and other gaming engines. And integration with other plant systems, well, that's one of our core strengths. So all of that to say, Nigel, is that imagine navigating through a complex facility where you can see and interact with everything, whether you're using it to design a plant, train field personnel, or even planning how you're going to decommission the plant at the end of its life. It could be done at the plant or remotely, wherever the project offices are. Even several of these ORCID IX stations network together for geographically distributed teams to all be in the same 3D world, all working on the same assets, no matter where they are. So it's a pretty powerful thing that we're bringing to the market.
Yeah, I think that, you know, maybe I'm mindful of time here, and maybe we can have a final question to the panel. You know, we started around the challenges around the present situation due to the pandemic. I've been hearing lots of positivity from you panel representing your companies. What about the future? You know, what about enhancements to simulation? Clearly what Michael's just spoken about there, simulation and the environment. So Pablo, what have you got to say about that one then, about the future? Where are the growth opportunities for new business? I don't hear Pablo's audio.
No. Sorry, I have my mic mute. Sorry. It's an interesting question, and probably the first question that we should answer our own is how is going to be the new normal? I don't have the answer. Okay, I don't have this answer, but well, we would figure out 6 months ago that we were to be in this situation. We can anticipate the future based on the current information and trends, but everything may change out of our control. Okay, I think that it's well known that the probability of a second peak of the pandemic by the end of this year is not a negligible situation, and we need to be ready to minimize these consequences. Okay.
And what do you say? What are your ideas here from your?
If you are to look at the earlier explanation that is looking at the panel operator as well as the field operator, you know that the current limitation is that the heat mounted device has to be connected via a wire, and that puts on the, let's say, Oculus or other HMD, right? Unlike the so-called the solution that Michael has actually shared with us, but at the lower level, one of the possibility is that with this mode of training, you basically, for panel operator, you can only interact with one person. But if the SOP within the field itself has got many people in the field that you need to interact itself, then current this area you can't achieve that. So one of the possibility is that if 5G can enable this, that means all the VR modules will be in the cloud itself. And Oculus has just announced a couple of weeks ago that this 5G enabled Oculus will be actually available next year. So that can be one of the model, just like OTS, like you know, the mahjong table, and there are 4 persons sitting there. All of them are just using the headset. You can actually push out scenario, and each one do different parts of the SOP. So that can be something in the future.
Cool. I think that 5G is a topic for a discussion in itself. But Michael, you heard there from Han, there's possibly some new business for you already in Yokogawa. And I saw when you told us about the ORCID IX that I thought you had an emotional moment, but it turned out to be a cough. But you're passionate about this, and you know, for you, it looks like that's a key business area for the present and the future for you.
Yeah, absolutely. I mean, our core process simulation business continues to march on. But we are very excited about the work that we're doing with extended reality and Orchid IX, and we think it has a lot of promise for the future.
Yeah, and I think other companies, Alex, I'll bring you in here around artificial intelligence and human machine learning and so on. So Alex, if I can ask you about, you know, the present and the future business opportunities, where the focus is.
Yeah, I mean, Nigel, you've mentioned it. One of my favorites at the moment is next, based on my latest experience with augmented reality. So what I really like, it's really my personal favorite, and I think we can benefit in the near future from AR as well. That we say that is really also a new behavior, how to manage these information we are connecting from different sources. And having these HoloLenses and all these glasses ready to be used for augmented reality on top. The artificial intelligence, I think, is one driver that will enable all of us, if we do it the right way and if we really start to use it, to really go for next level of business models, that we can really totally change the behavior between EPCs and own operators, that we really can transfer and extend our business cooperation behavior and simulation based on artificial intelligence and the interconnected data models. That will maybe totally change some of our business models we are at the moment familiar with, or where we are basing our companies on. At least within Siemens, it's a super big topic next to 5G, as you have mentioned, Nigel.
Yeah. Super. Well, I think this was a really great session, some great discussions and insights for everybody to take home today, ourselves and the attendees. I'd like to thank you all, Michael, Han, Pablo, Alex, you know, for giving us your time and engaging afternoon with these discussion points.